In episode 33, titled Production versus Non-Production, Separation, Blast Radius, and Governance, we treat environment separation as a reliability and risk management practice because the real point is to keep experimentation from becoming customer impact. The exam often frames this as best practice, but the deeper idea is that environments exist to contain different kinds of risk, and the boundary between production and non-production is one of the most valuable containment boundaries you can build. Production is where availability, integrity, and compliance obligations are highest, while non-production is where learning, iteration, and change are more frequent, so the two worlds should not share failure domains casually. When environments blur together, outages, data exposure, and privilege drift become more likely, and incidents become harder to investigate because logs and ownership are mixed. A clean separation also makes governance simpler because you can apply different controls to different risk profiles without endless exceptions. The goal of this episode is to make environment separation feel like a practical design decision you can justify based on impact tolerance and compliance, not a checkbox you follow blindly. Before we continue, a quick note: this audio course is a companion to the CloudNet X books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. Shared resources are a common reason testing accidents impact critical services, because a change in one environment can unintentionally affect the other when the underlying dependency is the same. Shared resources can include networks, identity providers, domain name system zones, shared storage, shared logging pipelines, shared gateways, or shared quotas and limits that create contention. When test traffic hits a shared database, it can degrade production performance or corrupt production state, even if the application code is different. When a test deployment changes a shared firewall rule or a shared route table, it can break production access paths, causing an outage that feels mysterious until the dependency is discovered. Shared quotas and capacity can also cause problems because a large test run can consume resources and starve production, creating performance incidents without any production change. In exam scenarios, when the prompt describes test changes caused customer impact, the likely culprit is a shared dependency that was assumed to be harmless. The remedy is not just better testing. It is reducing shared failure domains so mistakes in non-production remain contained. Separation is what turns a mistake into a learning event instead of a customer incident. There are multiple separation options, including accounts, subscriptions, virtual local area networks, and distinct domains, and each option creates a different strength of boundary and a different operational cost. Separate accounts or subscriptions provide strong isolation because they separate billing, quotas, and many administrative controls, reducing accidental cross-environment impact. Network separation through subnets and virtual local area networks provides traffic-level containment, preventing accidental reachability and making it easier to apply distinct security rules per environment. Distinct domains, such as separate identity and domain name system domains or separate naming conventions, reduce confusion and reduce the risk of name collisions and credential crossover. In practice, organizations often combine these options, using separate accounts for strong top-level isolation and then using network segmentation and naming boundaries within each account for internal clarity. The exam often expects you to recognize that separation is a spectrum and that the right choice depends on the scenario's risk tolerance and operational realities. Stronger boundaries cost more in management and sometimes in complexity, but they also reduce the blast radius of mistakes. The key is choosing separation that matches the consequences of failure rather than defaulting to one pattern everywhere. A reliable decision method is to match separation level to impact tolerance and compliance needs, because the question is not how separated can we be, but how separated must we be to keep risk acceptable. If production downtime or data exposure has severe consequences, then strong isolation, such as separate accounts, separate identity domains, and separate networks, becomes justified. If the environment is small and the application is low risk, lighter separation might be acceptable, but even then, you want to avoid shared resources that can cause unintended cross-impact. Compliance requirements often push towards stronger separation because audit expectations include access controls, data handling rules, and evidence that non-production access cannot easily become production access. Impact tolerance includes business impact, safety considerations, and reputational risk, and those factors should guide how many shared failure domains are acceptable. In exam scenarios, phrases like regulated data, service-level agreements, customer impact, or strict change control are signals that stronger separation is expected. The best answer is usually the one that acknowledges these signals and chooses separation that reduces cross-environment risk without creating unnecessary operational burden for the scenario described. Separation is a business risk decision expressed through architecture. Data handling is a central part of environment separation because using real sensitive data outside production expands exposure and often violates governance expectations. Non-production environments are frequently less monitored, more widely accessible to developers and testers, and more frequently changed, which increases the likelihood of accidental exposure. Using real production data in test can also create integrity risk if test actions modify data that is later assumed to be trustworthy, or if data is copied without proper sanitization and then shared beyond its intended scope. A safer approach is to use synthetic data, mask data, or carefully controlled subsets that preserve the shape of production without exposing real identities or secrets. Even when realistic data is needed for testing, it should be handled with explicit controls, access restrictions, and retention rules that match its sensitivity. In exam scenarios, when the prompt mentions compliance or sensitive data, the best answer typically emphasizes avoiding real data in non-production and applying strong governance to any necessary copies. This is not only a security concern, it is also an incident prevention concern because data leakage events often originate in less controlled environments. Treating data as a first-class boundary element is part of making separation real. Change control differences are another reason separation exists, because non-production often needs faster iteration while production needs stability, and mixing those rhythms creates friction and risk. In non-production, teams may deploy frequently, experiment with configurations, and run load tests or chaos tests, which are valuable for learning but not acceptable directly in production without tight controls. In production, changes should be planned, reviewed, and reversible, because untested changes can create outages and compliance issues. Separation allows you to implement guardrails in non-production, such as limiting blast radius, using constrained permissions, and having clear rollback, while still allowing faster cycles than production. This also supports governance because you can enforce different approval paths and different deployment constraints per environment, reducing the chance that a quick test change slips into production without review. In exam scenarios, when the prompt mentions rapid development cycles and also strict uptime requirements, the correct answer often involves separate environments with different change control expectations. The key is that speed and safety can coexist only when environments are separated and controls match the risk profile of each. Separation, turns change control from a blunt barrier into a tailored process. Imagine a scenario where a misconfiguration in test should not reach customers, such as a test deployment that accidentally opens an inbound mule or changes a routing entry that would be catastrophic if applied in production. The design goal is to ensure that such a mistake stays inside non-production boundaries so that customers never see it and production services are not degraded. Strong separation might include a separate account or subscription for test, separate network ranges, and separate gateways so that changes cannot propagate to production control planes. Even within a shared organization, access policies should ensure that the credentials and permissions used for test cannot modify production resources, reducing the chance of human error crossing the boundary. Monitoring should also be environment scoped so that test anomalies do not drown out production alerts and so that production incidents are visible immediately. In exam reasoning, the best answer in this scenario typically emphasizes isolation of control plane and network boundaries rather than relying on be careful processes. A design that prevents cross-environment impact is stronger than one that merely detects it after the fact. Shared identity systems are a major pitfall because they allow privilege creep across environments, where access granted for non-production gradually becomes effective production access through group sprawl and role reuse. If the same identity provider, the same groups, and the same administrative roles are used across environments, developers and testers may accumulate permissions that are appropriate for non-production but dangerous in production. This can happen through convenience, such as granting broad roles temporarily and then forgetting to remove them, or through role definitions that are too coarse and apply to both environments. Shared identity also complicates incident response because it becomes harder to tell whether a credential was used appropriately in test or inappropriately in production when the same identity is involved. A safer pattern is to separate identity domains, or at least separate roles and groups clearly by environment, with production access requiring stronger controls and tighter governance. In exam scenarios, when the prompt hints at excessive permissions, audit concerns, or accidental production changes by developers, shared identity is often the underlying cause. The best answer typically includes environment-scoped roles and clear separation of privileged access paths. Identity is not just who you are, it is what you can change, and production should be more protected. Shared domain name system zones can create confusing name collisions because the same name may resolve to different endpoints or may be overridden by test records, causing unpredictable behavior across environments. If test and production share a zone and use similar naming, a test record can accidentally override or shadow a production record, sending traffic to the wrong place. Even without accidental overwrites, split horizon behaviors can create situations where clients resolve to different answers depending on resolver configuration, making troubleshooting difficult when some users hit test and others hit production. Name collisions can also occur when internal service names are reused across environments without clear namespaces, causing applications to connect to the wrong dependencies during deployments. A safer approach is to use distinct zones, distinct subdomains, or naming conventions that make environment identity explicit, reducing the chance of accidental crossover. In exam scenarios, if a prompt describes some users hit the wrong environment or services resolve inconsistently after a test change, shared domain name system is a strong suspect. The best answer often involves separating zones and ensuring resolvers are environment aware. Names are control plane artifacts, and mixing them across environments is a classic way to create chaos. There are quick wins that reduce drift, such as standardized templates and baselines, because consistent infrastructure patterns make environment differences deliberate rather than accidental. Templates ensure that networks, security groups, logging, and identity roles are created consistently, reducing misconfigurations that arise from manual one-off builds. Baselines define what normal looks like for each environment, making it easier to detect drift when test starts resembling production in unsafe ways, or when production starts inheriting test-like lax controls. Standardization also supports automation, which reduces human error and allows changes to be reviewed as code, improving governance. In exam scenarios, when the prompt emphasizes operational efficiency or repeatability, template-based approaches often align with best answer logic because they reduce long-term risk while supporting speed. Drift is a hidden enemy because it accumulates slowly and then shows up as a surprise incident, and baselines are how you keep drift visible. The practical point is that separation is not only about building walls, it is also about keeping those walls maintained over time through consistent patterns. When templates and baselines exist, environment boundaries remain clear even as teams iterate. Monitoring should also be environment-aware, with separate alerts and dashboards, because mixing signals across environments creates noise that can hide real production incidents. Non-production often has frequent changes, experiments, and intentionally broken tests, which can generate alerts that are meaningful for developers but irrelevant for production reliability. If those alerts share the same channels and dashboards as production, teams become desensitized, and real production incidents can be ignored or delayed. Separate monitoring does not mean ignoring non-production. It means aligning the signal to the purpose, such as using non-production dashboards for development health and production dashboards for customer impact and service level objectives. This separation also helps incident response because it clarifies what is actually affected, reducing confusion when test issues occur simultaneously with production issues. In exam scenarios, if the prompt mentions alert fatigue or missed incidents, environment-separated monitoring is often part of the solution. The key is that observability is part of governance, and governance should respect that production and non-production have different definitions of normal. Clear separation of monitoring channels supports both faster development and safer production. A memory anchor that captures the core boundary elements is separate people, data, identity, and networks, because these are the domains where separation must be real to reduce risk. Separate people means production privileges are limited and tightly governed, and non-production access does not automatically grant production change capability. Separate data means sensitive production data is not casually replicated into test, and any necessary copies are sanitized and controlled. Separate identity means roles and authentication paths are environment scoped to prevent privilege creep and to support auditing. Separate networks means reachability and control planes are isolated, so a misconfiguration in test cannot redirect or degrade production traffic. This anchor helps in exam questions because it forces you to evaluate separation beyond different subnet, recognizing that many incidents are identity and domain name system problems rather than pure routing problems. When you can recite this anchor, you can propose a separation strategy that addresses the most common cross-environment failure modes. The exam rewards this holistic view because it reflects how real governance works. To end the core, propose separation for application, data, and administration, because these three elements define most environment boundary failures. For the application layer, you separate deployment targets and network exposure, so test endpoints are not reachable through production paths and cannot be confused by shared names.
For the data layer, you ensure test uses synthetic or masked data, and that production databases are reachable only from production application segments, not from test networks.
For administration, you separate privileged roles and access paths so that developers can iterate quickly in non-production, but require stronger approval and narrower access for production changes. You also ensure logging and monitoring are environment scoped, so actions and incidents can be attributed correctly without confusion. In exam reasoning, the best answer often combines strong isolation for data and administration with controlled, purposeful connectivity where necessary, rather than attempting to share everything and rely on process alone. The goal is to make it hard for a test error to become a production incident, even when humans make mistakes. When you can propose separation across app, data, and admin, you are thinking like an architect. In the conclusion of episode 33, titled Production versus Non-Production, Separation, Blast Radius, and Governance, the central governance goal is to contain risk so experimentation and fast iteration do not translate into customer impact or compliance failures. Shared resources create hidden coupling that allows test accidents to affect production, so separation options like distinct accounts, subscriptions, virtual local area networks, and distinct domains should be chosen based on impact tolerance and compliance needs. You handle data carefully by avoiding real sensitive production data in non-production, and you accept that change control differs by environment, with faster cycles in non-production under guardrails and stricter control in production. You avoid pitfalls such as shared identity systems that enable privilege creep and shared domain name system zones that cause name collisions, and you reduce drift through standardized templates and baselines. You keep monitoring environment scoped so alerts are meaningful and production noise remains low. And you remember the anchor to separate people, data, identity, and networks. Assign yourself one environment boundary review by choosing an application you know and stating which people have production access, what data exists in non-production, how identity rules differ, and how network reachability is constrained, because that review is how you make separation stick over time. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.